Hello, I'm Abhinav and I work as a BMS algorithm development engineer and battery simulation engineer at Decibels lab. So at Decibels lab, we conduct various different tests on different types of lithium-ion cells, that is NMC and LFP type of cells. One of the tests that we have conducted is a thermal performance test on a lithium-ion NMC cell from Samsung. So this is of an 18650 format type, and the purpose of conducting this type of test is to observe and analyze how the cell's performance changes with respect to ambient temperature. So, namely, we have conducted static capacity test and pulse power characterization tests to analyze how the cell's capacity changes with respect to change in the ambient temperature, and also the resistance of the cell, how it changes with respect to the ambient temperature. So, this is conducted by performing these tests on the newer 5 volt 20 amp machine that is having a data acquisition device and a environmental chamber or a thermal chamber which can go from minus 25 degrees Celsius to plus 95 degrees Celsius. So specifically, we have changed the temperature from 0 degrees, 25 degrees and 45 degrees. So utilizing these three intervals of temperature, we have conducted the two types of characterization test, that is the static capacity test and the pulse power characterization test, which gives us information on how the discharge capacity of the cell and the resistance of the cell changes with ambient temperature. So the static capacity test is performed by discharging the cell at a constant current from maximum voltage to the minimum voltage, and the pulse power characterization test is performed by providing a series of pulses, that is charge and discharge pulses, again between the maximum voltage and the minimum voltage. You can see these profiles on the screen here, how the capacity changes with respect to temperature. You can see that as and when the temperature goes on decreasing, even the cell's available capacity also goes on decreasing. Along with this, you can see also the profile of the pulse power characterization and how this will return the resistance of the cell. And you can see that this is now an inverse behavior. So as and when the temperature goes on decreasing, the resistance goes on increasing, which affects the cell's terminal voltage. So these two parameters, that is the capacity and the resistance, can give us a very good idea on how the cell's performance gets affected with respect to the ambient temperature. So you can see that at 0 degrees, it is entirely different compared to that of 45 degrees Celsius. So this data can further be loaded into a lithium-ion cell digital twin, which gives us accurate idea on how the SOC, that is the state of charge, can be affected with the temperature. So by loading this data, that is the capacity data with respect to temperature and the internal resistance data with respect to temperature, we can get a very good idea on how the SOC varies with all these data points. You can find the download link here in the video description, and after downloading this data, you can upload this as a lookup table into the model, that is the cell model, and then further work on how the simulation will return the SOC, that is the state of charge at different temperatures. Thank you.